This video works through an exam question on regression. If we look at the question, we can see here that we're trying to find the least squares regression line of y on x, where x are some temperatures in degrees Celsius during weekdays in July, and y is the takings of a fish and chip shop in pounds. The first thing we need to do is to put these two lists onto our calculator. To do this, we put first the temperatures in list 1. If you've got a lot of things already there, you can either just type over them, or if there's too many, I'll just remind you how to do this. If there's too many, you can go to the top of the list and press this del A, which deletes everything in the column. It's more likely you'll be able to see this. This is the normal display. If you can't see this, press exit until you get back to there, and then it's F6 here to take you on to the second list of options, and then F4 as it's the fourth along here, F4 for delete all. So that will clear list 1 for you. Just press F1 to confirm that's what you want to do. We'll just put 3 of the temperatures in, so we'll start with 23, it's the first temperature, then 18, then 27. We then move across and put in our takings at the fish and chip shop. We've got 4290 as our first entry, then 3188, and finally 5106. Right, I'm not going to complete the list, but what we'll do now is we'll do our least squares regression. We can do this the way I showed on the previous video on correlation by pressing F2 for calc and then F3 for regression. Make sure that the setup's right, so we'll check that first, F6 for set, and because it's 2 variable we ignore the 1 variable rows. We want our x's in list 1, our y's in list 2, and frequency as 1 because we're not multiplying, we don't have any frequency tables, we're not multiplying any of those values by anything. So that's correct, so we can go back and we can either press F3 for regression, and if we do that it's x we want, which is F1, and then we just copy our A and our B, and that gives us the product moment correlation coefficient there. So we would get an A value of 213.4 and a B value of minus 642.6. And remember, it's in the form y equals A plus bx. So the equation would be y equals 213.4 minus 642.6x. Okay, I'm not going to write that regression line down because it's not the correct answer to the question. We only looked at the first 3 values for each. What I would like you to do now is on your calculators, complete list 1, complete list 2, and write the correct equation out. This is what you should have got. You should have got a B value of 191, which you get 2 marks. If you got between 190 and 192, but not 191, you'd have got 1 of those marks. And for the A-intercept, you needed 115 for both marks, but for 1 mark, anything between 93 and 137. And you should really write that in the form of y equals A plus bx. B is the gradient, A is the intercept. You could have done it without the calculator using the formula, which is given in the formula booklet on page 13. And that's just showing you an alternative way of answering the question and how you would have picked up marks if you'd approached it that way. But I would recommend the calculator, it's a lot easier. We're now going to use the regression line to estimate the shops taking on a weekday during July when the maximum temperature was forecast to be 24 degrees. In other words, we're going to make an estimate for when we think the temperature is going to be 24 degrees. All we do for this is use the equation in the form y equals a plus bx. The only unknown we now have is the x, and we put 24 in for x. So have a go, and this is what you should have got. So we put 24 in here, 115 and our 191 that we've already found, and that's what you needed for 2 marks, a little bit more leniency for 1 mark. For the next part of the question, we have to explain why the equation may not be suitable for estimating the shop's takings on a weekday during February, and describe in the context of the question a variable other than the maximum temperature for x that may affect y. Well, for this first part, you need to think about what we've actually been doing. We had data from 7 weekdays in July. So obviously making an estimation for a weekday during February is going to be a bit difficult, isn't it? It's very, very different in the context of a lot of things. School holidays, time of year, temperature, all sorts of potential issues here. And as long as you make a good case, you might want to use the word extrapolation, because we're extrapolating from the data, from the statistics we've got. For the second part, any valid variable will do. So you could mention anything else. Some of the things I mentioned before, like maybe falling out of school holiday time. So you might want to use something like rainfall or something like that. Might be all sorts of things. Let's have a look anyway at what options we had. So for the first mark, concentrate really on temperature. It's likely to be lower, obviously, in February. And here we've got rainfall, wind strength, sunshine hours, daylight hours, day of the week, public holidays, school holidays, all sorts of. And as long as you put something that's sensible, you'd have got the marks.